Hey guys, how's everyone doing? I just kind of got everything set up, so I haven't really kind of planned what's going to be going on for this, but from what I recall, there's not a ton left on this board, but I do have to make some changes with the bulk capacitance from what I remember. How's it going, Danny? Hey, Mickey. Hey, Claude. So, in after the last stream, um, your found an issue with my the calculation I used. I was off by a factor or a multiple of 10. So the input bulk capacitance should be 363 and not 36.3, which probably makes a little more sense. Um, but that's based on a 5 amp transient current, which is kind of arbitrary anyway. So if it's 1 amp transient, it's only requiring 14. If it's 5 amp. Hey, J-Tax. Hey, Johnny. I'll give a minute for some more people to join. All right. So let me just kind of get my bearings on this again. I was hoping to go through this beforehand, but I kind of had some stuff I had to get done over here. So where's our... All right, so yeah, we have the 247 mic bulk electrolytics. So what did I use for the series inductance? 560 nanohenries, which that's kind of a rule of thumb. I'm currently in the process of finding a buck boost converter which can deliver 1.5. Well, JTAX, that's a pretty normal spec because obviously you're using it for a lithium ion battery, so they're pretty standard. Oh, using Eagle. Yeah, not a fan. Hey, is my audio good? Um, it's complaining on YouTube. Oh, no, it's not. So I'm guessing it's fine. Okay, so what I'm thinking for the bulk capacitors is just kind of waiting and see how much space we have, and just fill up however much space we have, and then testing wise, we can kind of decide how many are actually needed or not. I think that makes sense. Audio's good. Fantastic. Yeah, I don't know why. That's why like every stream I'm always asking if the audio's good. Oh, better than last stream. Fantastic. Yeah, I don't know why YouTube's always complaining about it, so it makes me think that it's wrong. Okay, so let me... Oh, we also need to do... I guess since we're going to shrink down the board, let's figure out the connector. So does anyone have any nominations for what connector to use? Yes, it is YouTube. That is true. You never can figure them out. Oh, fidget key, digit key. And sorry about my keyboard. I was actually just thinking about that the other day. I need to get a keyboard with some like brown key switches or something on stream because I know how obnoxious that must be. Maybe I'm using the wrong keywords. Hold that thought. I think we're gonna finish up this kind of early. At least I think, and I can show you some stuff later on if we do finish. So suggestions. Yeah, I like the sound of it for sure. Um, Suggestion on connectors. Um, do we want bare wire to board, right? Um, Now something that's terrible searching is like DigiKey for or any site for connectors. It's really painful. Not sure if I'm on then. It's late here. Ah, dang. Yeah, that's the problem is it's like it's so hard to do these at a good time for everybody. So this is what it technically needs to be like 15 amps at least. Okay, so any of these will work. So these are direct to wire, so just a screw terminal. I think that probably makes the most sense for like an evaluation style board. Since you're not gonna have like an actual connector cable assembly built. And do we want right angle or do we want vertical? These are going to be, or I guess this will be the exact same as the output. But this, I think, makes sense being a vertical just because you can connect it then from any direction, where if it's right angle, you only have the one side. But for the output, since the output is going to be a lot heavier wire, I think if that's sticking straight up, it might be a little awkward. Oh, hey, Gary, I'm glad you joined. Yeah, connectors suck. So yeah, since nobody has any feedback, I am gonna make an executive decision and do right angle. Or I guess we can do those 45s can be nice also. Um these are like the bog standard, like the Phoenix or Worth. They kind of suck, but they're cheap. These are pretty nice. I've used actually I think this exact series, but I've used that in the 45s. Yeah, Phoenix. I mean, those are pretty standard. Um, these actually, they're built by obviously a ton of different brands, but the Phoenix Connect and what? Yeah, but there's so many different types. I mean, you can't just be like all Phoenixes are good because this style where they're just like little vertical nubs. If you're using like a heavy gauge wire and you tighten the screw too much, it'll twist out of it. Like the actual plastic part will bend. All right, well, I'm not going to spend like half the stream looking for a connector. So let's see what actually has okay stock also. Oh, and I guess see what pitch we have. Okay, so 5 millimeters pretty common. So let's do these Phoenix. They've got a bit more support. Yeah, ferrules definitely help, but I actually, one of the boards that we're still building, they use, I had thrown on some ferrules for one of their screens, and I guess the ferrules, I don't know, they have a way of breaking everything, and they actually didn't want me to do the ferrules anymore because they were having issues with them breaking. But they can literally break everything. Oh, do I have to make the footprint? Crap. I was definitely not I was hoping not to have to do that, but I still don't know what symbols are what in. Oh, footprints. Um, there we go. Yeah, I don't know why they changed all the logos for each of the components. It's kind of a pain. Okay, they want it to be a 1.3 millimeter drill, and they even changed this. It's like they changed everything on here. Let's do them a little bigger. I don't know if we'll be able to go that big, just because, that's a little excessive. Just because it's going to be a pain to solder, even with thermals, just because of how big it is, obviously. Or how much copper there is. Okay, and now, how big is this? So it's 4.5, 4.5, 4.5, and 2.5 on the other side. X 4.5, 4.5, and then Y. No. This is 4.5. Now, X is 2.5. It's 2.5 over from here. So that's 5, I think. I'm sure my math of that in my head was wrong, but we'll see. Okay, what is A? Maybe I can see this on the same screen so you actually know what I'm talking about. Okay, I'm trying to find what the dimension A is. Of course, they make it super hard to actually see. A. I have no idea. Well, 10 by 9, is that what I have? Not even close. How do you decide whether or not... I never use a downloadable footprint. The only time I'll use really KiCad footprints at all is for streams. But seriously, where's the dimension A? I have absolutely no idea. But I don't even think we need that because 2.5 on this side, 2.5 on that side, 2.5 here, and then Y is 4.5 with the total 9. So 4.5 on both. So yeah, we're good, I'm pretty sure. Well, there's where you're wrong, Johnny. It doesn't assure that it's going to work. It assures you that if it's a mistake that you made. There's a big difference. I would know. Trust me. Okay, and I'm not gonna bother. I guess I'll do a courtyard at least. But I'm not gonna bother with anything else. Just because I don't want to take up any more time than we have to with that. Yeah, they're always done by interns. It's like the most important part about building their own products are done by interns. It's like, yeah, that's a great idea. Okay, so that makes that makes the board quite a bit bigger. Holy cow. Yeah, so I think we're gonna have enough room for some more bulk capacitance. Something I love with the new KiCad is having the edge cuts as a rectangle is so nice rather than them all being lines. I never make mistakes like when it matters. Yeah, exactly. That's how it always is. Leadership footprints are made by people that have never attended. Exactly. Many greetings. I love KiCad. I have just memories of how I started. OrCAD on a CJ. Oh, Darius. Gary knows all about that. All right. God, there is so much empty space on here. It's ugly. Okay, so the obvious change, we have to move this down, but it's like there's no sense in tightening this up. So then, for sure, let's move this here. No one else has ever heard of KiCad? Then they're obviously not staying up to date with anything. Okay, I want to get this centered. So Y is 16. 19.5, so 2, I think, gets us there. 16.5, 20. Why? I thought my grid is 5. I didn't think that's how it worked. 19.5. Close enough. Okay, so we can move that there. Move this down here. Does anyone else have any thoughts before we start finalizing some of the traces? Where's my 0 axis? Right here. It was just at 37.5. Did I mismeasure that? I did. Okay, 37. Okay, so no one else has any thoughts here, then I'll start moving this down, which I guess we can make it in line. With this. One day they'll fix that. And the selection, apparently. Holy cow. Yeah, so what I always do is I'll do the entire route just with thin traces like this because I know I'm going to have to redo them anyway, and then I'll redo them all at the beginning or all at the end once I'm happy with the placement. I find it saves an immense amount of time. And before anyone asks why these two are not routed right here, this is the feedback. It uses like a feedback differential pair. And this is the noisy switching node, and they want it to be as far away as possible. So that is why. Hey, Patrick. 37 divided by 2 is 18.5, right? I think so. You'll have ground pour on top side? Yeah. I just only have it on an inner layer so I can make sure that everything is connected directly, and then I'll go ahead and do that after. If yes, then this feedback may not work properly. Trace will be inside of a pour. Yes, but that's why you put a keep out around it. It's always a good idea to have a ground pour on your routing layers. You just can put a keep out around it. But, and this is something that me and Gary have talked about in the past, even though they do say, and I still will, put a keep out around differential pairs, you shouldn't really need it because it's going to couple better to each other or the pour below it than it will what's over here. But I guess it's still good practice. Okay, so now this is center. This has to be on the corner, which I guess isn't ideal. We just have so much dead space. Does anyone else see anything to save space? Here, I'm going to add some more bulk capacitors, so that won't be a huge deal. But mainly in here, oh, we can slide this whole, oh boy, that's another thing I need to, it's like that I don't like I'm not selecting it. So I'm thinking we can move all of this here, potentially. Kikit has only been around for 29 years. Exactly. Left under, I don't know what you're referring to. Because if we are to move this down here, then we take all of this and move it here. Yeah, it really doesn't save much. I mean, it does. It does, because then we can scrunch this up. So yeah, let's roll with that for now. So to whoever, Danny, you asked making them wider. This is exactly why I don't do that at the start, because I know with 100% certainty that, ah, crap, I forgot what's the command to select the whole trace. Dang it. I remembered it last time. U. Got it. ln1 and 2 will be solid ground. Yes, that is correct. But yeah, if I had spent my time making this like all proper trace widths and everything and doing pores right at the start, this would be an absolute nightmare, because I would now have to redo all of these for a second time, so just waste a lot of time. Yes, I remembered the U. Just took me a minute this time. Okay, so how do you choose trace widths? And there's a bunch of ways. When you're routing, you can hit Q and do it on the fly, which is how I do it. Or you can set your net classes. Deleting Y. So we can save a crap ton of space here. Okay, so let's get this roughly here. Oh, wait. I don't see any reason we can't bump this back. Why is it not letting me drag a trace? What? Did I mess with the router? Electrically. Oh, how do I? Got it. Does anyone have any idea? Like, this is the type of stuff that gets... Now it works? What in the world did I do differently? I've never even seen this box. I have no idea. Well, that's gonna make this an absolute nightmare. How do I choose them? So it depends on something like this. For the majority of the important traces for this board, it's going to be based on the amount of current, because this is going to be an absolute beast of a 0.3, 0.5. It's an absolute beast of a regulator, so there's going to be like 15 amps. So matching the trace widths for that current is going to be the primary thing. Some lessons about net class. I don't use net classes. I do it all on the fly. So like if I need to change it, I do that. I guess net classes can be faster. Gary, if you're still in here, do you use net classes for trace widths, or do you just do it on the fly like I do? I'm pretty sure you just do it like I do, because I've never seen on one of your layouts having it set up with net classes. Yeah, that's why people ask me why I don't use like nightly and like work projects. It's like, well, this is why. This is one reason. Oh, hey, Jeremy, you use net classes? Net classes. Yeah, I can totally understand why you would use them. It's just something I've never. I honestly, I don't think I've ever even messed with it. I've just never found a huge need. I've never noticed doing it on the fly being that big of a pain. Oh, what did I do? Why are my vias different? Oh, they're not? Oh, look different. Oh, I don't like this at all. Guess that's a little better. I usually create a few sizes, then use hotkeys. Yes, that's something that I've wanted to start doing, but like I said, I've never. Tell me these vias don't look different. 0.3, 0.5. It is different. 0.25. See, and the way it defaults on vias is really obnoxious too. I don't understand that. Okay, so that's all good there. Now we need to drop this down. Usually in 2 or 3 high power mid 5. Yeah. So you're doing exactly what Arnie is saying. You're kind of just using them as predefines then, not like for every single individual net unless I'm misunderstanding you. And that's the only pain of doing it this way. Any good advice with stitching vias? Put as many until you get like tired of putting them. Nowadays, you really don't pay extra for them, so you really might as well have them. I usually will start at like a 5 millimeter grid, place them everywhere, then drop down to like a 0.25, place them in the places where the 5 millimeter missed it, and then just go on and so forth. But it also depends on the board. Okay, so that's good. So that saves us a ton of... Oh, forgot one. Putting them around clock sources. Yeah, that's... You can do that, like, with crystals. It's called, like, a guard ring. Um, that definitely can help. Gotta go by. See ya, J-Tax. Thanks for stopping by. Okay, so that actually made a massive, massive difference. I don't feel near as bad with how much wasted space we have. Okay, so I don't think we can tighten anything up here. We've got that. And why is there just a random trace chilling? T Electronics, how's it going? Really? It didn't let you know? YouTube's crazy. It's like I have what? I made a YouTube post, a scheduled stream, and then a reminder, and it's like it still doesn't remind people. What a pain. Are you in the Discord? Because I also post there. And if anyone else hasn't joined already, join the Discord. Gonna be up to 500 members pretty soon. So now I guess I'll swap these around. When you have quite fast I2C, like 3.4 megahertz, do you use Saturn to calculate, for example, crosstalk? Heck no. Not with something that slow. 3.4 megahertz still, I mean, that's not anything you really have to worry. I mean, of course, don't route your clock line along the entire board next to a analog trace, but you don't have to worry about it typically. I forget the old saying, but it's something like if the slowest thing on your board is under a gigahertz or something, you don't have a high speed board, so that you don't have to worry about it. Can't use I2C and fast together. That's what I was gonna say, but figured someone else would say it. And this, just to reiterate again, this is all gonna be on a pour once we finalize this. What is this? Oh, it's an LED. I was like, that makes absolutely no sense what that's there for. Did I do this in 0402s? Oh, yeah, I had changed it. So, something like that. Okay. So I think we're getting ready to start finalizing some of these traces. Anyone else see anything that we can change? Perfect. So that is centered. This one we can't really center, but that's okay. Turn that 2-pin header by test point 90 degrees. Turn that 2-pin by test point around 90 degrees and tidy up all the traces and vias by the bottom left of it. I'm failing to see what that does. Yeah, I got nothing. But yeah. Oh, I really can't drag that. Okay, so now it's letting me drag it. But we can for sure tidy up some of these vias. And it says these are supposed to be differential pairs, but as far as I could find, they didn't say a single spec or anything with it. So I haven't the slightest idea of what they actually need with it. What is this? VDD, so that's for the internal power decoupling. So we're tacking VDD onto how our pull-ups are, so that's not super high priority. Yeah, so I guess let's focus on this because I'm definitely not happy with how this looks. So this these two traces we can't really mess with. That we can't really change. They won't let you drag, press the D. Oh, okay, so at least that works. Whoa. Why did it make two traces? That was weird. Okay, so I'll do that now. So I'm not seeing right off the bat really any major simplifications here. What are these? Just series. Oh yeah, just protection. So those we want to be closer to the connector anyway. So those I don't want to mess with. These are our pull-ups, and then they go in. Yeah, I mean, it doesn't look insanely neat. If you rotate the I2C resistors, it could clean things up. Oh, good call. I think that will. How would you simulate an LT Spice microcontroller from power side current draw on different frequencies to see drop on voltage rail? I wouldn't. That's something I would do testing. You can get in like some really big time sinks by trying to simulate everything. It's useful, but it's only so useful. I mean, it depends what you're doing. Capacitors for I2C are not needed. Gotta be a little more specific. There's a pretty tight spec on I2C, how much bus capacitance it has. And that includes, obviously, any parasitics. So if you exceed that spec, it's not going to work. So you normally don't add any external caps. That looks like crap, but we can worry about that in a second. Yeah, I think this is gonna help a bit. Yeah, the resistors was meaning a lot less jumping between layers, yeah. Okay, so I mean, actually that did not help as much as I thought it would. Yeah, that actually didn't help other than that one that much at all. Unless I'm missing something else that you were saying. Component placement, prettiness. Oh, absolutely. That's the most important part about doing a layout is how pretty it looks, for sure. And what I like about doing these live streams like this is I know when I was starting, it's like you would see a layout. Why did I put a via there? You see a layout that's done like really well and you just get kind of intimidated because it's like, oh man, they went through and did all that. When in reality, it's like you start doing a layout and it looks like absolute trash and you just kind of mindlessly start changing things until it starts to look good. So that's why I like doing these because it's like I'm pretty good at routing, but it takes a while. So I think it's kind of cool just showing that side of it where when you see like it's why they call it artwork exactly, especially when you had to do it by hand back in the olden days. Okay, so this yeah, I don't know how much rotating that helped because now the clocked pin is kind of a pain to get. There's just not a great way to do any of this that I'm seeing. I mean, sure, we can definitely just kind of... Why did you do that? I don't want to, I really do want to finish this today on this stream, so I'm not going to spend too much more time on just adjusting this. PCB layout is also something like if you're worried of a ceramic capacitor capacitance, how do you know where the capacitance is after built in? Are you talking about like offset from heating in the reflow oven or what? That's why the auto router can never replace us. Yeah, it certainly can in some circumstances, but not as a whole. The key is any professionals who are using an auto router, you still have to have somebody to program it. So, oh, that sucks. Um, I mean DC bias and AC bias. You can use an LCR meter. A good LCR meter will let you do it at different DC biases and different frequencies. That's pretty much the Whoa. That's pretty much the standard way to do it. Okay, yeah, I don't know how much this made things better. I'm expecting AI to enter the auto routing scene where the auto router is moved. Yeah, but it just takes so long when you get to that point, which not saying that's necessarily a horrible thing, but we'll see. You could take SDA and SCL lines a little to the left and route the line from bottom up. Take them to the left and route them from the bottom up. The issue is we have to tap power. Yeah, because we have to get the pull-ups to this pull-up voltage. But yeah, that's what screws us. Oh gosh. But this is our pinout. So if we were to move these three resistors down here and just adjust the pinout. Thanks, I didn't know that. So it's always thanks, I didn't know that. So it's not always the best to save on equipment. Yeah. I don't usually like using all those vias. Oh, trust me, and I know Gary right here is looking at this and he is not happy with me. But I haven't heard him offer any advice. Yeah, it's a no-brainer. We control the pinout. So let's make use of that. So let's put pin 6, which is the S alert. Yeah, let's swap 3 and 6. It's almost too obvious. I can't wait till they implement the back annotation on KiCad. That's something they have been missing for quite some time. Wire on top of the PCB, right? Hey, just wanted to say I've been watching your videos past few weeks. They've really helped me to learn and build a confidence. Thank you, mate. That's what I do it for. That's what it's all about. I'm glad you have gotten something out of it. And if you haven't already, make sure you're joining the Discord. Yeah, this is going to help clean it up quite a bit. So now we can put that there. Now, what if we move all of these? Yes, I also forgot about Patreon. If you guys haven't been here recently, like a month ago, I set up a Patreon account. It's in the description. I'd appreciate any support. Any of it is much appreciated. Okay, I love how I said I'm not gonna get into fixing all this, and yet we're halfway through and have spent time making it pretty, but it is artwork. So these are gonna stay. So if we move, I guess let's just start and move these two down here. External voltage, top layer there. Let's get rid of this. Okay. So we can put this like that. Okay, I got an idea. What if we do this? We can always adjust the specific placement. Now, sometimes the design process vias are a step on the road. Yeah, right. I know it is funny in this day and age where you really don't get charged for extra vias. You still spend this much time trying to get rid of them. What really makes this hard is that differential trace down here. It makes it so there's really not a ton of options. So now if we move P good on this same line here, and actually maybe we do this. I mean, it certainly can't wait until Microvias are free. Yeah, right. I don't know if that's gonna happen anytime soon. So this certainly looks better, by quite a bit, but it still has about the same amount of vias. VDD trace from 3-pin header to the right. Does that help though? If we're gonna do that, then I think it makes sense to go back here. Yeah, that might make it a little bit prettier. Unless you're out of the differential trace around the connector. Oh, Gary, why'd you have to say that? I think that's the way it should be done. You're gonna make me redo all this, aren't you? So what Gary's saying is if we scrunch up all of this and move it a little bit tighter, we can route this differential all around here. No, I think we have to because this is an analog trace. So that gets it away from the I squared C lines. So I think that makes it better in every way. You had to wait till now to mention that, didn't you? Yeah, that fixes it. And for those of you who don't know, Gary works with me at MT. He does the vast majority, pretty much all of our layouts. He is a literal guru with this stuff. One day I'll get him on stream and show us how he does it. Then you'll really learn how to do a layout. Yeah, that's gonna make it so much better. Yeah, it's like when you see it like that, it's like, oh, that was obvious. QA with Gary, yes. Yeah, I was mentioning that to him a little bit ago that we need to do something. Best way to teach, wait till. Yeah, that's about what he normally does. Okay, let's move this all up in here. Yeah, this is so much better. P good need via. No, I don't think it's gonna need a via at all. Yeah, this solves like every issue we had. Okay. See, guys, I didn't need any help. I had this all figured out. Yeah, so the big key with this, not even the that it looks a lot better, is now it's not near any of the I squared C. And since this is an analog feedback trace or pair, that makes a massive, massive difference. So whoever asked about the I squared C and Crosstalk, this is a scenario where it's not like hugely important, but the fact that we're able to get this away from the I squared C obviously is going to help. It's not that it was critical. Why not placing pull-up resistors in line with series resistors like P good? Because I want to be able to run the trace straight down. Where if I had it, yeah, actually, no, I agree. I think that's probably a better way. I don't think it's a huge, huge difference, but sure, I can see that. Okay. That's definitely my favorite part about doing layouts. Not that, like I said, I do a ton day to day. I do all the schematic side much more. Is once you figure something out and it goes from that mess to this, it's such a nice feeling. Okay. I think I'm pretty content there. Anyone else see anything? Why did I not have an in-between zoom? There we go. I do not see anything, but I'm gonna go to the bathroom real fast. I'll just keep this screen open so you guys can check it out and let me know if you see anything, anything else that needs to be changed. All right. Question, would it help turning the inductor 90 degrees clockwise? Yeah, definitely not. Missing trace from output cap to output connector. Yeah, we're gonna have pores there, so I'll start working on that once we get there. Alright, so no one really has anything, so then I guess we can start on this. You don't want any mounting holes. Good call. Since this is an evaluation board, we shouldn't really care about if they're perfectly spaced, so I think we can maybe just throw some wherever. What do you guys think? I have absolutely no preference on that. This is an LED, and I am not going to have that in the middle of the power section. That makes no sense. I do not know what I was thinking. So this will have somewhere down here. Do you also leave the ground plane to last? Yes. So the reason I do that is so I force myself to see where the grounds have to be connected to. You could always just put rubber feed. So what Gary does is he won't even have, and correct me if I'm wrong, he won't even have a ground plane in here at all, and he'll manually have to connect all the grounds. I don't feel that. I don't usually go that far, but I don't have a top ground pour, so I at least force myself to put the ground vias to the inner pours, especially on a 4-layer board, but either or. So does anyone for the mounting holes? After we just condensed all this, I would rather not have to enlarge the board to have 4 corner mounting holes. are you guys fine with like, I mean, I guess we kind of do have to enlarge it for mounting holes. Under to the right of the input terminal if it's M2, then left of the inductor. Yeah, because I want to have at least one more cap here. So that leaves us space here, here. We could probably squeeze in 4. So here, 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 and there. Is everyone fine with that? Anyone have any opposition to it? And just because I know somebody is going to call me out on it, this is a time I'll use the default libraries because a mounting hole is a mounting hole. For prototype, 3 holes are enough. That's a pretty small board. 3 are good, 2 are too wobbly. Got it. And then are we fine with M2s? For spacing wise, why connect to ground? Great question. The simple reason for doing it by default is if it's connected to ground, you can always isolate it by using a non-conductive washer. If you don't have them connected to ground, you can't. And this isn't a pad, so this actually needs to be one of these. Or we can do the pad vias, probably even better. Mounting holes after you think of them, of course. Daniel, hey Kyle, again a bad time for me, been super busy and I'll catch the vid, see you on Discord. No worries, man. Catch you on hopefully the next one. Nice new setup with the green screen. Thank you. Yeah, it's been a pain getting it. Still not perfect. I mean, you can see it's not amazing, but it'll get there eventually. Multiple footprints found for C3. Oh, right. That's just because that's there. At least M3 holes. Oh, really good. Well, I'm glad you like it. At least M3. Yeah, we can try. Let's see how that works. Okay. Yeah, we can switch, try to go to M3. Reminds me of a recent layout with a schematic engineer got his header. Yeah, that's not good. Let's see what M3s look like. So still think it's better to leave floating. You can't just blindly say it's better to ground them or better to isolate them. It's such a loaded opinion or question because it's so dependent on your actual board and your setup. So that's again why having them tied to ground like this, in my opinion, is the best way because it gives you that flexibility to isolate it or non-isolate it whenever you need to. Where if you just never connect them and you need to ground it, it's game over. You have to redo the board. But truth be told, in the majority of circumstances, EMI wise, ESD wise, it's better to ground it. Obviously, there's situations where it's not, but it's one of those things. When in doubt, ground everything as low impedance as you can, and more often than not, that's going to be the best way. So we can put here, here, here. So yeah, we can do 3. If everyone's fine, we can do 3 M3s. We really wouldn't be able to fit M4, 4 of them. But I think, 2 or 3 people said 3 is fine. Totally haven't done that myself. Are you referring to the needing to ground your mounting holes after and you didn't have them at first? I tie all screw holes on the board and then choose plastic. Yes, that's exactly what I'm saying. Either do a plastic enclosure or you would just isolate them. But the plastic enclosure is another one of those things. More often than not, if you can get away with it, having sheet metal is the way to go. But it depends. Does it need fiducials? Yeah, I mean, if this is something, and maybe let me know again here, would people here be interested in buying this if I were to try to sell a few of them? Because then if I'm actually gonna build some with the pick and place, then obviously, yeah, it needs fiducials. No, no, adding this SWD connector. Got it, yes. No, that would certainly be much worse. Yeah, just make sure, if you guys don't go into streams a lot, when you mention something, make sure you tell me what you're referring to because I have like a 20-second delay from when I say something to when you're able to comment. There's a delay. So I, a lot of times, have no idea what you're referring to if you're not explicit. I would buy it, been meaning to try out. Awesome. So we're going to need to keep cramming this stuff in here somehow. Crap. This test point's going to be so close to this inductor. I love how here I am thinking, oh, I'm going to finish this board even before time's up or before 2 hours. And here it is, likely probably not even finishing it. That's how it always works, though. So where... what if we do something like this? I normally wouldn't space it over traces, but I think that works. You could move the enable pin further to the left, get rid, place Ian vertically north of Ian jumper. Yeah, I think this works. God, that's so annoying that I can't just drag this without explicitly hitting the D button. I mean, it's obviously a bug or I changed a setting somewhere. Oh man. Well, that's a pain. Oh, that's such a pain. Okay, clearly there's a better way to do that. Apparently it thought I said okay, Google. It's like if you have an Alexa and you accidentally say it. Rotate 90 degrees clockwise. Oh, yes. That will help a lot. Good call. Sometimes you need a V if I have one or more. Yeah, I mean one or two. I mean you're gonna need a lot more than that. Rotate connector 180 is no option. What connector? But this is good. We're fine like this. Now we're nice and cleared away from everything. Um So let's hold off on the other two. Also rotate the jumper 90. Oh, now I see it. Yes, got it. Oh gosh. Both I squared C north of 2 pin. Yeah, I like that. Why not S? Yeah. Yes, now we're definitely getting, which is like what I said earlier. That's my favorite part of doing layouts is it's like you just stumble along looking like a complete fool, and then once it all comes together, you're like, yeah, that's exactly what I meant to do. Which is again the reason I like doing these streams, because it's not as intimidating when you see that even a really good layout starts out looking like crap. It's just you keep iterating it. I keep trying to pan and zoom your screen. Yeah, I don't think that's going to work too well. Okay, now I think we're good. Oh, I am shocked with how many people were mentioning other stuff. Nobody thought to move the VDD. We don't need to have that go on the bottom. Let's move this up. And this is the part I don't like about doing layouts, is you end up spending so much time doing things that are absolutely useless other than making it look good, and you end up spending so much more time. That's like Gary whenever he does one of our layouts is like an hour after he finishes and we've done the Gerbers and everything, he'll review it and it's like, oh, there's like 5 things that should be changed, but don't actually have to. Do you guys ever use Altium? No, I stick with KiCad just because. Oh, yeah, I forgot I don't have the pour. If I were to use Altium all day, then for the streams and everything, I'd have to relearn so much stuff. The only part I like about layout is the Gerber output. Okay, now that is pretty freaking slick, I have to say. Okay. In one of the videos I think I'm going to gonna do actually might be pretty soon, because there's been like 3 or 4 people on Discord recently working on 2-layer boards. Enable jumper seems way too big than required. Yeah, but 2.54 millimeters is a standard jumper, so everyone has them. Is just kind of like how to do 2-layer boards. A lot of people I think misunderstand it and what's important, and basically by laying out like even a 4-layer board like this would be a pretty good 2-layer board, because there's no traces on the bottom side. Like literally, we have 2 traces on the bottom. And for a 2-layer board, the whole goal is to have a simulated ground plane like you have in a 4-layer. So you want to keep the bottom pour completely empty of traces when possible. So I think that'd be a pretty cool video. Okay. Now, does anyone see anything else before we start finalizing this? Sorry, I don't mean to keep scrolling. It's hard to get to the right zoom. I don't see anything. Place the ground plane. I think I'm still gonna wait a minute until we get the main traces going. You could push the connector upwards towards the third screw via. I don't think it benefits anything, because right now it's dead center. But sure, we could. One thing, you'll be pressing down SG and the worse. I don't know what you mean. Oops, above comment. All right then. Okay, so then I think we're good. So let me. Oh, I don't have Saturn PCB on this computer right now. The left bottom trace could be eliminated if you. Whoa, boy. The left bottom trace could be eliminated. The left bottom trace could be eliminated if you want to route between connector pins. Like, how do you see that stuff? Like, that's hilarious. Yeah. Yeah, good call. It's just used for a pull-up, so who cares? So now we will literally only have one trace on the bottom layer. Do we care that it runs alongside this? I don't think so, and we can just push this out. Because it's just a pull-up line, so it's not like we're going to have a ton of noise on it. What I was saying is you need to support for the screw terminal top left. You'll be pushing down. Good call. Good call. I see that. So yeah, we'll try to fit this one over here. Really good point. You could use KiCad's built-in calculator. Yeah, that's true. I always forget that they have calculators. I always use Saturn or advanced circuits, which I really shouldn't use advanced circuits. Okay. Oh, come on, KiCad. Usually results of built-in calc. They all give you slightly different. Although trace width should be pretty similar. Controlled impedance is always different because they're using different calculations. So yeah, now literally just these two traces and that's it. Awesome. Okay, so I'm just using advanced circuits. So we're doing, we'll say 15 amps. I guess keep it in millimeters. Let's keep it at 1 ounce just for now. Ambient temperature, let's start with a 50 C temporize. So that's 4 millimeters. So this might need to go to 2 ounces. Because at 2 ounces, we're looking at right at 2 millimeters, which 2 millimeters is doable. So let's see how we're looking with 2 millimeter. And I'm going to use pores for everything. Is 1 ounce equal to 35 micro? I don't remember all the conversions. Gotta run. All right, Gary, it was sweet having you here. I'll talk to you later. So we can start just with a trace and then see. So let's see, 2 millimeters Oh yeah, we've easily got 2 millimeters for this whole run. Let's see, maybe 4? Probably not 4, so they'll probably be 3-ish. So at 3-ish, if we were at 1 ounce, oh crap, uh, 1 ounce, 5. So what about a 70? Yeah, so we might be at 2 ounce no matter what. We'll see though. 1 ounce equals 35, 70, yeah. Okay, so let's start doing the pours. And you know what we have the option to do, and I think we'll do it, is, and this is something on one of the first videos I ever did on YouTube, I did about doing high power boards where you stitch the top and bottom pours together. We can probably do that here. So let's keep ground open for now and just start with 12 volt. And we can do just top layer for now. Zone priority 1. Do solid for now. And that should be good. So actually, now that we're going to do, won't 2 ounce copper be a bit pricey? Oh, this is a 4-layer board. Yeah, it might be. But I think, I wasn't even thinking, we can stitch. So that's going to be our issue trying to put a mounting hole here, is it's going to interfere with our pour significantly. Crap. So I do not have a great solution for that right now without making the board bigger. Anyone have any thoughts? Because what GN had said is we'll be using a screwdriver here to tighten down this connector, and if our closest mounting holes are over here, you're not going to have this very supported. Why not use an M2? Yeah, we might have to for this. Yeah, let's move whole board to the left. You have space on the right to do, and then move power connector. Move whole board to the left. Yeah, but that still effectively makes the board bigger because I'm going to shrink this whole thing down. I think we're going to have to go to at least see what 2.5 does. Got it, Jet. Keep up the good work. All right, man. Thanks for tuning in. Yeah, so that probably works. And we can't really move these over. I forget what these are. Bootstraps. The bootstrap cap and resistor. So yeah, those are pretty important. It still sucks that it takes up this much from here. guess we can always, just to balance it a little bit, just move this up a touch. And that should be enough, because how much space do we have if we do right here? Yeah, that's 3.5 millimeters, and if we double stitch it, that's 6, 7. Okay, back to the pour. So in the name of the game, when you're doing pours like this for high-powered stuff, is it doesn't matter like if it's the most direct route, you want to have as much possible copper as you can, because you need to think of it as like basically a heat sink, and the more you have, the easier it's going to be able to dissipate heat, and it'll lower the resistance. So even if it looks a little goofy, you want to have a ton of copper here. What in the world? There we go. And this is another thing where I just will kind of roughly do it at the start and then come back and make it better. So like instead of going straight across, having a little bit extra copper there helps with power dissipation, just that ever little bit. So what I'm saying about stitching, and this is something you don't see a ton, but it's pretty fantastic, is you stitch top and bottom, so you have a pour on the top and bottom layer, and then you stitch these together with vias, so you effectively double your width here. Don't forget that you still have to put in the 2 other resistors. Why'd you remind me? Oh, piece of cake. Let's do it like this. Crisis averted. And then when you're doing your trace width calculator, kind of take it at your smallest point. So we're at 3.5 millimeters, so doubling that to 7. And since we'll have a lot of vias, that helps with thermal dissipation as well. So if we have one, oh yeah, we're gonna be plenty good. Okay, so that's that. Now it goes to our ferrite, and now so you have 2 ounce with stitching, exactly. That's the goal. Oh, what's the name of that net? C11 pad 1. And I don't force it to do 45s because it sucks on KiCad, honestly. It like makes it really hard to know where you have to terminate it. So I tend to just do it like this and then adjust for 45s later. And if you're wondering why 45s, because it looks good. There's really no reason. Same reason nowadays, pretty much why you do all 45-degree traces. It doesn't actually have usually a sound reason, but it just looks better. In one thing, I do try my best. With pours, you can spend an ungodly amount of time making these look pretty, but it's hard. Like, there's just so much nitpicking you can do. So, as much as I'll try to spend time like we did optimizing the regular layout, I try my best not to get bogged down with doing this part of it just because it isn't usually worth it. Okay, so now we have this. What are you doing? Oh, it's going down. If you make the corners too sharp, the electrons will fly out. I know, I love that joke. It's funny, like on Reddit, how often people will make that joke and some people actually won't get it. It's like, fair play. Okay, so now here's our main power in. So that via just takes it down, so we can just flood. Oh, I don't like this. What is this? This is a 22 mic. Why is it there? Yeah, this kills it. I don't know if we're gonna make this one work. And that's too many. We're already more than we would need. So yeah, let's ditch this. And I know I haven't added this one to the schematic yet. I will. And I'm pressing insert to do that, to add a extra node. That's just kind of personal preference. I like to make as few pores as possible and just join them together. But if you don't and just do it separate, really doesn't matter. But see, this is what I'm talking about, how you can get down quite the rabbit hole by trying to make your pores perfect. And as much as I say I try not to, you still end up always doing it somewhat. And it also makes your pad entries really nasty sometimes. That's usually what I'll spend more of my time on with pores. Oh crap, this is all. Right. And yeah, this part gets kind of tedious, so sorry if this stream is getting a little monotonous. If I don't fully wrap up this board in this stream, I'll just probably finish it off stream and then do the video later on, just because I don't think people want to watch me do these pours all day. Question: I need to carry 30 amps via a leg of a MOSFET. PCB calc says I need 8mm plus copper, so why doesn't the 1mm track under the leg burn out solely the solder making the connection? It doesn't. I've often thought about that, and as long as you... So there's two different specs when you're, and this is something I've thought about doing a cool video in the past. So there's basically two specs for current carrying capacity of a board. The first one is like burnout, to where if you try putting 30 amps through a 0.25mm trace, it's going to burn it up, end of story. The second one is overheating. So if you neck down the trace to like a small pin, it's going to be able to dissipate all that heat in the rest of the pour, just like a thermal. It's the same reason why if you have a thermal, it doesn't burn up. As long as it's thick enough to where it can carry the current without catching on fire, it's going to be able to dissipate that heat. But yeah, really, really good point to bring up. Would you rather have your pour go through the bolt caps, then the filter caps, then the pin instead of teeing out? No, because the filter caps down here is what your loop is with the actual regulator. The bolt caps are for the lower frequency stuff, so they can be farther out. You want these as close as possible because your loop, depending if it's on or off, your input loop is going to be in here or on this side in here. So you want these to be as close as possible. Okay, so that's that. And I know someone's going to mention, what about pores for ground? Normally, I would discreetly draw them out just for my peace of mind, but we have ground pores on every layer, so they're going to be fine. But yes, proper procedure would be to do a separate ground pore just so you can see and validate where it's coming from, but I'm not going to bother. Okay, so now this... Let's move over here. Oh boy. And I'll explain why I'm doing this in a second. Question, why not connecting the filter caps directly to ground pins instead of vias? Don't have space. I mean, yes. Oh, you're talking about right here. Sure, it's going to be. It's going to be because this is all going to be a pour on the top side, but you still want it connected down to your bottom ground because that's where the loop's going to be on all layers. Especially, and I'd mentioned this in the last video, this is going to have thermal vias here for sure. So having it on all layers is beneficial. Okay, so the reason I moved that is because I need to move this test point over here to give me more space to do our pour to the inductor. So I guess another change that would be helpful, I'm not going to do it right now because it's not worth it, would be to run SDA up a little bit and move all of these to the left. So then this trace can be to the left, and that lets us do our pour a lot easier here. But, like I said, I don't think it's probably worth it right now. Net L1 pad 1. Oh, and I didn't do zone priority for that. And again, I'm oversizing the pour by a lot. Oh, crap. Oh, don't mess it up. Okay. Solely because thermal dissipation. And once you have your stitching vias here, it'll help a lot acting as essentially a separate heat sink as well. Yeah, so that'll definitely be useful moving those traces over because that necks down this trace quite a bit. I guess we just do like that. And here's where I was saying it makes your pad entries kind of a pain. Hello? There we go. 0.25 zone. Oh, zone priority is already set. So yeah, if we can move this stuff over. What are these? That's VNs. Those actually are kind of important. So we can't really move them that far, but we'll see. Okay, so there's our pour there. And now I don't have a single electrolytic on the output side. I think we probably should. Okay. So now let's see how we want this. We have space, what, for one electrolytic here? And these electrolytics that I have spec'd are rated for... let me check. They are spec'd for 35 volts because they're supposed to be on the input side. So this will end up using a lower voltage. So we can probably get this to be maybe not 220 microfarad, but up there, definitely over 100. So that helps us quite a bit. But footprint wise, we can use it just for now as like a mock-up. Gotta run. Thanks for the stream. Thanks for tuning in, Matin, Maton. We'll see you next time. Okay. And now I'm going to add one of these electrolytics to the output side. And what I'll do later on is I'll make sure that I'll see if we have any other size of caps that we can put in there that might help us to get a little more bulk capacitance there. Oh, crap. I didn't mean to click that. Where'd that cap go? Oh, it's right there. I was gonna say, what in the world? And as a reminder, with a buck regulator, the output caps and filtering are way, way less important than the input side, solely because we have that inductor, so it forms an LC filter. So that's why you can be way more nonchalant with how much bulk capacitance you have on the output side, where the input side, you don't have that inductor. So if you don't have some sort of filter there, you're kind of screwing yourself. And you're not really going to have a good so we can easily put another mounting hole. So I'll go ahead and do that after as well. And this could be here. Yeah, so this is going to turn out really nice. The datasheet states that the converter is stable with any kind of output cap. That's probably why you didn't add. Yeah, yeah, I remember we were going through that last time. I forgot. Which is funny because on their simulator in the first or second part of this, I went through it and they recommended like 9, 10 mic or 14, whatever, 22 mic caps on the output side. And it's just ironic that they say, yeah, you can use anything. We recommend using 9, but it doesn't matter. It's like, well, I don't think you can have it both ways. But yeah, the bulk capacitor on the output side is more so just for whatever you're using this board for. Um, if you have long wiring or if you don't have a lot of bulk, I guess the main reason would be if you don't have a lot of bulk capacitance on that board or whatever you're powering, this helps to smooth out any surges you might have, any low frequency stuff. So yeah, that's a ton of copper there. So yeah, I think we're easily going to be able to get away with just a 1 ounce copper board. So this is just a light, an LED indicator. So ground. So we might have to not. So we might have to redo this and make this part only on the top layer because our ground, and this is why it's helpful to draw these pores sometimes, the ground on here is going back into the ground of the regulator. So since we stitch this here, we don't have near as much copper when it necks down. So I'm thinking we keep this on the top and bottom, but right here we go just to the top. So now our ground coming from our connector is this entire section down here. And I think that will make a big difference. But yeah, we've got space for another electrolytic. Oh, if we do the mounting hole, maybe not. But we have space for a bigger footprint electrolytic here. And then these two indicators can go essentially right there and tap that in. So you don't leave the underside of the inductor empty. Yeah, I had mentioned that briefly last time. I don't know. Every other manufacturer you talk to or read their app note, they say something different. Some of them will explicitly say to leave it empty. Others will say explicitly to not leave it empty. Same with, and this was something we had talked about on Discord a little while ago. Some manufacturers for AC or series resistors in a differential pair, some app notes, and this is even TI, so some TI app notes will say you shouldn't have any copper under series resistors. In a different app note by TI for this same interface, they will say make sure you have copper under there. It helps control the impedance. So I don't know. I've never not done copper under anything, and I've never had an issue. I certainly see the theory behind it, but especially with this, where you're worried so much about thermal issues, I would much rather have a beefy piece of copper here. But to that same token, I don't see an issue with doing this. We still have so much copper here that I don't really think it's going to be an issue. So we could certainly do something like this. And that doesn't bother me in the least. And then that gives us a little bit of clearance here at least. Alright, so that I think is a good place to stop. The layout's essentially done. I'll just tighten this up and add the other electrolytic. And my plan is to do just a single video on this once I order the first few boards and test it. So it'll be like a condensed version going through the schematic, going through the layout, and then testing the board and doing some EMC tests. And then at that point, I can go ahead and gauge how many people might want to buy the board or just get the design files and whatnot. But yeah, I appreciate it. I know not as many people stuck it out through those pores, but for those that did, I appreciate it. And like I said, this will be the last one on this. I'm not sure what the next series for streams will be, but definitely let me know if you have any ideas. And if you haven't already, join the Discord, which is in the description. Also, check out my Patreon. Any support is much appreciated. And I will catch you guys in the next stream or on Discord. Have a good one, everyone.